Hello everyone, welcome back to the next video. In today's video I will show you how to do image segmentation using MediaPipe in a Flutter app. So first I'll show you the output. Now this is only applicable for Android. That's the first thing. Second thing, the output is little off. So I'll show you what I mean. So there is this button called pick image, and there are four types of TensorFlow Lite models which we will have to download first. I'll show you that as well, how to do that. But firstly I'm using this selfie underscore segmenter.tf Lite model over here. I will later on show you where to replace this model. I click on the pick image button, it opens the photo pickers app, and I will pick one photo, and here you can see that it is able to separate the selfie from the background, but as you can see it is a little bit off. Okay, so I'm not really sure what the issue is. I think it is a Flutter specific issue because I didn't face this issue for native Android development. Similarly over here, as you can see, I'm facing the same issue, and here I will pick one third image as well. Okay, next I'm replacing this selfie segmenter with deeplab underscore v3. So I'll show you that output as well. It is very similar to this output which we have. So I'll just click on pick image. I have just restarted the app, like build the app again, and here you can see it is more or less the same. Okay, next I am using this hair segmenter, which will help us to colorize the hair of whatever the image is. So I'll just click quickly. Yeah, as you can see, again it is a little bit off, unfortunately. In case if you are able to figure out why it is off. And lastly I'm using the selfie multiclass 2456 by 256, and this is the output for it. As you can see, like it's able to detect the face as well as your hair and all that stuff. So yeah, let's see how to do this. So first you will have to go to this TensorFlow Lite documentation, sorry, this MediaPipe image segmenter documentation. You will have to go to the overview section over here, and from over here you can download all the TF Lite models. So I am using the selfie segmenter square, but if you want you can use landscape as well. Then this is for the hair segmenter, this is for selfie media class, and this is for deeplab v3 as well. So you can know more about this by reading on this, when to use which one. Then you will have to go to your Android project. Inside the go to your Flutter project, go to the Android folder, go to app, src, main. Inside that create an assets folder and drag and drop whichever model you want to use. Next you will have to go to build.gradle, and here make sure you use min SDK version 224 because that is what is required by MediaPipe. Also I have added this to dependency which is required for register for activity result, which will help us to pick image from the photos app. And here I have used this MediaPipe task vision dependency for image segmentation, and here I have used this coil dependency for loading bitmap into an image view, and I have also used constraint layout, which I will come back to in a bit why I'm using it. Next you will also have to go to settings.gradle and make sure you update the Kotlin version to 1.9.0. Next inside lib main.dart I have just refactored my homepage widget. I am using stateful widget, and here I have created a method channel called pick image platform, and here I have created one variable for image URL. So once the user picks an image, I am sending that image URL from native Android side to the Flutter side. So here as you can see I have this text button, and on press of it I am just calling pick image channel dot invoke method pick image. You have to use the same identifier of this as well as this on native Android side as well. Once we get the result, I'm assigning it to our image URL, and if the image URL is not equal to empty, I'm using a size box, and here I am using this custom widget which I have created, and I'm passing our image URL. So for that I have created another dart file, and here I have used one identifier called my image view, which is a stateful widget, and here I have created a creation params map. So once we get the URL, I am assigning it to that particular map, and this did update widget so that our widget is updated every time the user picks a new image. and this is boilerplate code for displaying any kind of a native view for your Flutter project. Next, you will have to go to Kotlin. First, you will have to go to main activity.kt. Here you will have to extend Flutter fragment activity, and next you will have to create variable for method channel result, and inside configure Flutter engine I have first registering our image view. Next I have created, once we register the image view, we create a method called method channel, and here I am using the same identifier which I have defined it on the Flutter side. Once pick image is called, this method is called like this variable gets called like get content.launch array of image /star. So this gets called, and here we get the URI, and I use the method channel to send the URI from Flutter side, from a native Android side to Flutter side. And here I have created this overlay view. Now I have just copy pasted this overlay view from the documentation itself. So you can go to the Android documentation, and here you can just click on this overlay view.kt file. You can copy paste the code, and so here I'll just slowly scroll through it in case if you want to copy it. So basically what this file does is that it helps us to do the image segmentation on the image which you have selected. So here you can change whatever colors you want to have. Next I have created a factory class. Again, this is boilerplate code which you have to write every time you create a native view for your project. And inside my image view.kt, so in factory class I am referencing this my image view, and inside my image view.kt again you can copy paste all these imports. Here we are using first constraint layout. The reason why I'm using constraint layout is because I want the overlay view and the image view on top of each other. Next I have created this image segmenter. Then using image segmenter.options.builder I'm using set base options, and here you can change whatever TF light model you want to use which you have inside the assets. Make sure the name is proper, and it is for running mode of image. Category mask is true, output confidence is false. And here I have just created variable for image segmenter, and inside get view I am returning constraint layout, and here I am just calling image segmenter dot create from options, and I am passing the context as well as the options. Then here I have set some ID to our constraint layout as well as layout params, which is the width and height. Then I have defined some constraint set. Then for our image view I have defined one ID, added it to our constraint layout, added some width and height, and this code is basically like setting the image views top, bottom, start and constraints to the constraint layouts top, bottom, start and end. Similar thing we are doing for the overlay view as well, just like we are doing it for our image view. Then I am just applying our constraint layout, and here I am passing our URI to this display method. Then with the help of URI we are converting it to a bitmap, and we require a bitmap of argb underscore 8888. Then we call this scale down. We scale down the bitmap with the help of this method. Then we convert the scale down bitmap to MP image, and here we just call image segmenter dot segment MP image. And once we get the result, if the category mask is not equal to null, we just set overlay view dot set results. We can use the byte buffer extractor dot extract and pass our category mask as well as the width and height of our MP image, and we use the load method from coil to load the bitmap to our image view. So yeah, I think that's it. Unfortunately this is only for Android. At the time of this recording it does not support iOS, as you can see. But yeah, that's it. Thank you for watching. Bye.